Alright, this one says you can row at 80 minutes per minute in stationary water. Rowing upstream in a river, you cover a certain distance in 1 hour. Rowing back, you cover, with the current, you cover the same distance in 45 minutes. What is the speed of the current? So you imagine you're rowing upstream, right, the current's coming against you, right, so let x be the current, and you're rowing at 80 meters per minute. So you have to decide, is the current moving with you or against you? Well, if you're going upstream, it's going against you. So 80 times x, 80 minus x, times the time it takes you, right? Because that's velocity times time is equal to distance. So you're covering the same distance. So remember, velocity is equal to distance over time. Therefore, distance is equal to velocity times time. So that's what we're doing here. So this is your speed, and this is the time it takes. Now coming back downstream, you're rowing at 80 again. However, the current's now working with you, so you're going to add the current to your speed, and you make it back in 45 minutes. So you have this linear equation to solve for x, because x is the speed of the current. So x is the speed of current. So it's a simple linear equation. You multiply out, so we get 480 minus 60x equals 45 times 80, which is 3600, plus 45x. Okay, and you move some things around. If you 480, whoops, this is 4800, sorry, not 480. 4800 minus 3600 gives you 1200 on the left side. And if you move the x's to the right side, you get 105x. And so x is equal to 1200 divided by 105, which is about 11.4 meters per minute. That's the speed of the current. So in this problem, you want to make some coffee that costs $2 a pound, and you want to make it from coffee that costs $5.25 a pound, more expensive coffee, and cheaper coffee, which costs $1.25 a pound. And you're going to make an 80-pound batch. So the thing about this is a mixing problem. This is a standard mixing problem. In anything you want to mix two things to get something else, this is the way you would set up that type of equation and solve it. So we want to know how many pounds of each type of coffee to do that. So I'm going to just let x equal the pounds of the cheap coffee, which is $1.25 coffee. So let x equal something, and one of the coffees, so I'm going to let that equal the pounds of $1.25 coffee. So I have $1.25. My total cost is going to be $1.25, the cost of that coffee, times the amount of pounds I have. So it's $1.25 if you think of the units. It's $1.25 per pound times x pounds, and the pounds would cancel, and it gives me the amount of dollars I have to pay for that coffee. And so I'm going to add that to the amount of cost of more expensive coffee is $5.25. And how much of that coffee do I have? Well, I'm going to have 80. Why 80? Because it's an 80-pound batch. So I'm going to have 80 minus x. So I use x amount for the $1.25. I'm going to use 80 minus x for the $5.25 coffee. And that has to equal the total cost. What's the total cost? Well, I'm making 80 pounds, right? And that coffee is supposed to cost $2. So it's $2 times 80 pounds. Right? $2 a pound times 80 pounds. That's dollars again. So that will also be in dollars. Okay, so we multiply out everything here. We get $1.25 plus $5.25 times 80 is $4.20. And then minus 525x equals 160. And then we move some things around. If I subtract 420 from both sides, I get negative 260 here. And if I this is an x here. Sorry, I should add these two. So 125x minus 525x is negative 4x. And so x ends up being 65 pounds. Okay, so I need 65 pounds of the $1.25 coffee. And because it's 80 pounds I'm making, I'm going to need 15 pounds of the more expensive coffee, the $5.25 coffee. In this problem, this is a variation problem, and it's talking about, in this particular case, about the speed of the force of wind on a window. So it's a variation problem, and it says the force of wind blowing directly on a window varies jointly with the area of the window and the square of the wind speed. So those are things we have to get out. We have jointly out of this statement, area of window and square of wind speed. And this is the force of wind. So I'm going to let F be the force of the wind. Okay, F is the force of the wind. This is the force. And that varies jointly, so there's a variation. So we have this K, constant of proportionality, and it varies jointly with the area of the window. So I'm going to put A for area, and the square of the wind speed, or the wind speed I'm going to just label W, and we're going to square it because it's the square of the wind speed. Okay, so we got area for A for area, W for speed, F for force, K is that constant we're looking for, and so we have this equation. So then it tells me the wind is blowing at 30 miles an hour and the force is 150 pounds. So we said that 150 pounds is equal to K, and the area of the window is 4 by 5, so the area is 20. Right, 4 by 5, 4 times 5 is 20. We're assuming it's the square window, so didn't say that, but let's make the assumption it's square, or rectangular, sorry. So 4 by 5 is 20, and that's the area, and the wind speed is 30, so 30 squared. So we have 30 squared. So that's my setup, and we solve this for K. We do our calculation correctly. K is equal to 0.0083 repeating. So I wouldn't round too much. I'd keep some 3's here, but you do your calculation. 150 divided by 20 divided by 900. 30 squared is 900. Gives you 0.0083 repeating. So now, that's finding K. So now it asks me what force is exerted by this hurricane category 1 wind speed of 74 miles per hour on a 3 by 4 window. So we want to know F. So we say, well, F, so this is the second part, is equal to what? Well, it's equal to K, which is 0.0083 repeating, right, times the area of the new window now is 12. 3 by 4 is 12. And the speed is now 74 miles an hour, so we put 74 squared. So we have to calculate that out. So let's get the force. So we do this calculation, and we get 547.6 pounds. So the force of this new wind will be 547.6 pounds on that window. Even though it's smaller, the wind is faster, so you have all this force onto the window. So if the window can't withstand this and the wind hits it directly, it will probably break. Of course, all these numbers are hypothetical just to get across the point of variation.